Welcome back. I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, this is the course for project management, and today is the 8th lecture, which is the third session for the second week. So, as we were discussing the concept of expected value and how this concept of expected value is used, we will discuss that soon with the problems. So, for complicated project, we use the concept of a decision tree. So, decision tree is basically a so called node and arc concept. Node means the concept where you will basically have the decision being taken at a node, and the arc would basically be connecting the nodes. So, we will have the decision tree denoted by node and arc, but it can be the other way also, like arc and a node. So, for any event or any job for a project, you can either use the concept of arc and node or node and arc, depending on how you are trying to portray the activities. So, it may seem at the first go very complicated, but very simple, the how you basically delineate or draw the activities either using the node or the arcs. So, here the concept of probability for the decision tree, the concept of probability, if you remember, we had generally discussed the concept of probability in the number of days and what is the loss per unit of day for any particular activity is there, and how based on that how we find out the overall loss. So, considering distributions are not known or known, whatever it is, you can find it out. Here the concept of probability and conditional probability can be brought into the picture to have a good understanding about the concept of expected value as well as the risk of the project. So, let me first highlight two important things. How we do that? We will consider that in the problem in the third week, or by all probabilities in the last session of this week, second week. So, basically is the concept of the probability, which is marked here, and the concept of conditional probabilities. Condition on the fact something has happened, we will try to utilize that later on, try to find out the expected value and the risk of the project. So, now this is the first very simplistic diagram which I want the students to pay attention, because that will give you a fairly our idea that how the concept of probability, expected value and risk or the variance is used to find out decision trees overall outcome based on which we can use the concept of expected value to make a decision. So, what we have the nodes, which is number 1 marked here, and based on the work which is being done between 1 and 2. Say for example, you have acquired a land, and after the land is acquired. So, basically you will try to do 3 type of work. One is trying to lay the foundation for the big building, which would be, say for example, hypothetically the work being done from 1 to 2. So, this P suffix 1 2 is the probability or the concept of so called probability or condition probability which would come into the picture. So, for the areas or the concept of per 10 CPM, this probability would be subsumed in the problem in a different sense. I will come to that later. So, P12 is the probability for the work being done between 1 and 2. 1 and 3 is basically considered you are trying to clear up the area in and around where the building will be built. So, they are going simultaneously, there is no mismatch that one work has to be done first, the other has to be done second for the timing for 2, 3 and 4. And say for example, 1 and 4 is the work related to some litigation which would not affect your actual work being done. Say for example, there is some litigation regarding the road which is to be built up just outside the building. So, if that is a different issue, then you can definitely take up both of all 3 of the works, 1 to 2, 1 to 3 and 1 to 4, all of them simultaneously. So, but probabilities are different as mentioned, P12, then you have P13, then you have P14, which are the corresponding probabilities. Now, remember one thing, the probabilities would be different, Point 1, they can be either unconditional probability or conditional probability. Point number 2. Point number 3 is that the arcs which joins the nodes 1 2 or joins 1 3 or joins 1 4, the length of the arc is not to suppose that what is the number of days. So, the number of days would basically be mentioned alongside the probability, which we have not done here in this case. We will consider that when we go into the PERT and CPM concept, but it is basically just to show that there is a linkage between the nodes 1 2 1 3 and 1 4. So, this blue dotted line which you see for the first time, this one which is the vertical one, is basically a stage of the decision process. So, if you remember that we have been considering the problems from the project management perspective. So, there were some acceptance gate and there were some decision gates. So, the gates or the stage where you are going to take a decision, these vertical lines basically, that means the first one, the second one and the third one basically signify that if you are standing there, what would be your decision based on the overall feedback which you have corresponding to the probabilities and the so called other set of informations which you have. Similarly, consider from 2 to 5 you will go where the probability is p suffix 2 5. Similarly, you will go from 2 to 6, 3 to 6, 3 to 7, 4 to 7, 4 to 8, and the corresponding probabilities are given with p with the suffix of the initial node and the final node. Now, remember one thing, if you consider 6, it would mean that 6 can only start once the work related to joining between 2 to 6 and 3 to 6 all or both of them have been done. Why I am using the word all? There can be other jobs also which are ending at 6. So, here in this diagram I only have 2 such jobs. It can be other jobs which are coming here. Say for example, there is a job here which basically ends at 6. There can be job here which ends at 6. Say for example, 4 and 6 is connected. So, it may mean and actually would basically give you the information that job 6 can only be done after 2 to 6 is done, after 3 to 6 is done and after 4 to 6 is done. This is just for the information which I want the students to be aware that you can only start the job once the following jobs which are to be done are finished. Again coming back to, then you have basically the nodes 5, 6, 7, 8. Again there is a decision stage where you will take a look at all the overall feedback which you have for the project and make a decision here. Correspondingly, again you go from 5 to 9 or 10, 6 to 11 and 12, 7 to 13 and 8 to 14. Here just for simplicity, I have not considered that 13 is being affected by 6 or 13 is being affected by 5. So, those two concepts are not there. If they were, so obviously 5 would have joined 13, 6 would have joined 13 and you would only be able to start 13 once the jobs or the activities connecting 5, 13, 6, 13 and 7, 13 all are over. So, again the probabilities which are given p suffix 5 comma 9 till p suffix 8 comma 14 are the corresponding probabilities which denotes the suffix denotes the initial job and the final job or the initial activity, final activity or the initial stage or the final stage, whatever it is. In any project there are 3 factors also called the project control variables and they are needed or required for planned and controlled concept to take into decision the scope of the work. What is the scope of the work, what are the boundaries based on which the work would be done or the project would be undertaken, so on and so forth. What is the time scale based on which you are trying to do the work, because if you remember I did mention when we started off the concept of project management that time is one of the most important factor based on which the decision is taken about the relevance of the project and whether that set of activities are important or not. And obviously later on we will see the concept of cost or the concept of what is the schedule that would also come into the picture, where rupees or dollars or euros or yens whatever it is will be considered in order to take a decision whether that project is at all relevant or whether some set of scheduling can be done using some extra cost in order to reduce the time. Project planning, basic planning techniques would basically have the open creative technique, the forecasting technique, and the organization development technique. So in the open creative technique, you basically uses the creativity in organizations seeking new and non-traditional solutions, as that based on the new and non-traditional solutions, you will be able to find out that what is the overall way the project should be handled. The most widely used technique is the brainstorming sessions, where people from different areas of work who are involved with the project, basically they sit down together, give their feedback on different aspects, and all the salient points are basically gone into detail. So based on all the feedback which you have, the overall team gets the best set of feedbacks or best set of solutions or best set of, say for example, techniques which should be taken up to complete that project management work. The forecasting techniques can be either exploratory technique or normative techniques. So they are basically developed over time. So say for example, you want to forecast that what would be the sales of the moped, or you want to find out that what would be the average price based on which you can sell a certain product, whether an air condition or whether a fridge or a car, whatever it is. So you will have different type of mathematical and qualitative techniques based on which you can take a decision for the forecasting concept which you are going to use. And under the organizational development methods, you have the strength, weakness, opportunity, and threat SWOT analysis. So many of you may have done that concept of SWOT analysis. Basically, for any decision or any project to be taken, all the strengths of that project or the project work or the activities, all the weaknesses, who are the competitors, what are the environment based on which the work is to be done, what are the threat perceptions, whether the technology would be obsolete, and all these things are basically analyzed on a very detailed and minute scale, such that based on those feedback for the SWOT analysis and whatever other techniques you will be able to utilize. The brainstorming can also be utilized, a complement to the SWOT analysis or forecasting techniques can be used, such that you get the best solution by combining all the different techniques which are there at hand. After planning, we need to evaluate a project, and they are basically the direct evaluation method and the criteria based evaluation methods. So criteria based evaluation methods would be, say for example, you want to reduce the time, or you want to have basically an optimum time based on which the project would be finished, or you want to basically utilize the resources in such a way that you would not be utilizing more than, say for example, 20 crores for the project. Whether the time is important or not important may not be very relevant to the problem. But in general, we will see that in maximum of the project management techniques which are used in the practical sense, there the overall feedback is taken related to the time spent on that work, that overall amount of money spent on that work, different type of machines and equipment spent on that work, different type of human resources being utilized. So everything is considered such that you get the best benefit for that project, considering that you will be utilizing different resources at different levels of usage. Technical evaluation could be related to continuing with project management evaluation techniques. Technical evaluation should be related to functionality, the quality, the reliability. So how reliable the overall analysis has been, whether there would be any change in the cost structure, how sensitive is the cost of, say for example, the input material to the overall cost of the project. So consider that you are using steel. If the prices of the steel has a huge amount of effect on the project, then any small amount increase or decrease in the price of the steel would have a huge amount of impact for the project. So these things should be considered. It is also and often necessary to measure these factors on the economic units, such that based on the economic factors, if you remember, in the last to last class, we did discuss that for the problem where per unit decrease in overall cost or the loss was, say for example, 2000 rupees. So those economic factors should also be considered in the problems in order to find out the overall cost of the project. The most commonly used direct evaluation methods are the checklist and the pairwise rankings, as that based on the pairwise ranking you can make a decision whether the project should be taken. So obviously for the pairwise ranking, we will consider what are the different techniques of expected value and variance concept, or if required you can use different combinations of the moments to take a decision whether the project is actually viable and whether it's feasible, yes or no. For more complex problems, a method was developed by Santy in 1980. It's basically called the Analytical Hierarchy Process (AHP), and a bigger scope of that AHP is the Analytical Network Process, also developed by Santy in the 1980s and 1990s, and in the early 1990s. So, in the analytical network process, you basically try to analyze the whole project or a work as a network. So, there are, if you remember, in just in few slides back, we had the decision tree. So, that was a very simplistic decision tree. In the network, there would be loops and feedbacks, so that you will consider the overall projects as a network and basically take a decision based on that. So, where probabilities and conditional properties come into the picture. In analytical hierarchy process, there are hierarchies based on the hierarchies. So, there is no feedback loop. In the sense, feedback loop, what I mean is that for the hierarchy which are below, there are no arrows again leading back to the upper hierarchies. But in network, analytical network process, there are feedback loops or feedback arrows, such that you have to take that into consideration when trying to basically analyze the ANP network. While in AHP network or the diagram, you do not have that concept of feedbacks. In AHP, it uses a hierarchy of criteria that each alternative should be evaluated against. We first have to assign priorities to each criteria in the hierarchy. This is done using the pairwise comparison, and based on the pairwise comparison, you do that job. Next, we developed a set of matrices for the hierarchies, where all the alternatives are compared to each other for each criteria, and based on that, we take a decision. So, the profitability analysis of the project management is done such that the calculation of the profitability of the investment process is based on the projected cash flow. So, you will try to basically find out what is the present value of the cash flow, what is the future value of the cash flow, what is the concept of rate of return you will be using. Is it continuous compounding? Is it simple interest? Is it, say for example, compound interest? Or you will try to find out whether the interest rates or the evaluation of the cash flows would be based on a monthly basis or a yearly basis. And if at all, if the interest rates are fluctuating, so you have to take into consideration whether you are able to do your work considering the average value of the interest rate, or you have to basically consider some distribution for the interest rate. Based on that, you need to do the work. The cash flow shows the difference between the ongoing projects and the payment sequence which are there. So, say for example, if you are trying to basically analyze different projects, so one good method would be try to basically compare the internal rate of return IRR of the projects, and basically make a decision that what is the rate of return of the project, based on which you can take your positive or negative view. Another method can be, see for example, rather than going into the IRR, if it is difficult for you to calculate, you will just find out the expected value. So, in that concept of expected value, the concept of probability, what is the overall feedback of the rate of return for the cash, that would be considered. In case, see for example, the expected rate of return of different projects are the same, or there is some uncertainty that you are not aware of what is the expected rate of return of the project, then you will try to basically find out that what is the variance of the project. So, higher the variance, obviously you would not take a decision based on that fact, that as the variance is higher. There are three different types of outgoing payments. You have the capital expenditure concept, where all the projects would be considered on capital budgeting concept, and one is the operating expenditures concept. And there you will consider the concept of tax coming into the picture, and so on and so forth. So, obviously, time value of money along with the tax concept, along with the concept of IRRs, and so on and so forth, whether the money is there on as taken as a loan, or whether it's a liability of different types, would be considered in order to find out that overall what is the monetary value of the project. So, consider this. C0 is the initial cost of the project. So, R is the interest rate for the project calculated per year. So, I am basically considering R as interest rate per annum in a very simplistic sense, and consider it is deterministic, and where n is the number of years for which we will be finding out the value of the project. Then the total price would be given by this formula, which is basically here. So which means that if the price of the initial cost of the project is C0, then the total price would be given based on the fact that R is the interest rate calculated per annum, very simplistically, and then it is basically found out at in percentage wise. So what you will do is that for each value, for each year increase, the value is increasing to this. So if you have 100 rupees and the interest rate is 10 rupees, then consider a very simple example, and this is a just best way of trying to basically make the students understand. If you put 100 rupees in the bank pays 10%, such that is the rate of interest for the investment which you are doing, and after 1 year you will get basically get 110 rupees. So if you again put that 100 rupees not for now 1 year, for 2 years, then if simple interest concept is there, so it will be calculated by 110 rupees for the first year, 10 rupees for the second year, and so on and so forth. So if you consider one of the simplistic methodology how you find out the overall value of the project, it will be calculated, because this is the increase in the value of the money, this is the amount of money which you had in the initial stage. So hence the total price would be given by S, which is by this formula. If they are to be calculated on a yearly basis, so obviously it will happen that the per year calculation would come into the picture. So this I would basically mean that it is for either 1 year or 2 years or 3 years, whatever it is. So I doesn't mean only one. So because if it is for 1 year, then my calculations will be based on a time frame such that at t is equal to 0, I put my money, at t is equal to 1 year, which is 365 days or 12 months or 52 weeks, whatever it is, I take out that money, considering the example which I gave for the bank, and based on that I will try to basically have a overview that how the project would be doing if I basically try to analyze the project with respect to the investment in the bank. If it is for 2 years, then what I do is that I invest the money and the money stays in the bank account for 2 years. Then the calculations would be based on the fact that I is equal to 2. Now this Ri is given, which you will find it's totally different than R. If you remember, I had mentioned that R is the fixed value of interest rate for a long duration of time. But here if the R is changing, which is stochastic, then I obviously have to use R1, R2, R3, R4 depending on which time frame I am going to consider. But on a very simple sense, R is the average or all the Ri values considering, they say for example they are for 10 years, then what you will simply do is that find out the sum of all the R1, R2, R3 till R10, then divide by 10, then you find out the value of R. Hence the total cost of the project would be, the first term would basically be the cost of the project or the value of the project after 1 year. Similarly, if you consider, if I go into the second year, the term in the bracket R2 is the interest rate for the second year, and this square means 2 years. Similarly, if you go down the line, this n suffix is basically the interest rate, Rn is the interest rate for the nth year, and n is basically the number of years calculations you are doing. Now if you come to the value of C1, C2, C3, C4, basically they mean the value of the overall the cost of the project, which is basically either decreasing or increasing depending on whether depreciation is there or not there per year. So if C1 is the overall cost of the project, it means that C1 is basically the value at the beginning of year 1, and then based on that you calculate what would be the value of that project after the end of year 1, that is beginning of for the second year. So that would be calculated as given in the first term here. I just highlight it once more. So this is the value. Then if I go to the second year, beginning the second year till the end of the second year, or the end, beginning of the third year, this is the value, and so on and so forth I calculate. So if I try to draw it in the diagrammatic sense, what we have is this line, timeline. This is the value which I have. Say for example, input is happening, and these are the paybacks which are happening, and each gap which you have is 1 year. So say for example, the input cost is I with a suffix 0, which means that is happening for the time period when t is equal to 0.
So I am measuring along this horizontal line all t time. So this means t is equal to 1, t is equal to 2, t is equal to 3, so on and so forth. So at I suffix t is equal to 0, which is I0 is the initial cost, and consider this is C1, C2, C3, C4, which are the payback from the project. So if I want to compare whether it's actually good decision to take that overall decision for investing in the project, what I will do is that I'll calculate all the values of C1, C2, C3, C4 at time t is equal to 0, add up all of them, whether positive or negative doesn't matter, because if it is negative, then it will basically bring down the overall value. So these are the so-called returns which are coming into my pocket. This I0 is the value of the investment which I have done, and if I want to compare, I will find out just simple difference between the time value of money for C1, C2, C3, C4, so on and so forth, and compare it with I0 and make a decision. So if there are such different type of projects with different cash flows, I'll basically try to find out the value of the positive and the negative return, sum them up at time t is equal to 0, and compare the different projects at the same time. So the concept used for the calculating the project value would be the discounting factor, the net present value, the fixed discounting rate, the variable discounting rate, the internal rate of return, if you remember, the payback time, the return on investment concept, the discounted return on investment, and so on and so forth. So I'll come in trying to discuss all these problems of discounting factor, net present value, expected discounting concept, variable discounting later on. So what generally, apart from considering the qualitative concept, if you slowly go through the slides, you will understand that we have from the quantitative perspective till now, which is basically the 8th lecture, which is going to end within another 2 or 3 minutes, we have considered the concept of decision trees, which means we will definitely do a decision tree problem in another within 1 or 2 classes. Plus we will also consider the concept of expected value and how decision trees and expected values can be combined. And then we will try to find out the net present value concept of money, the IRR concept, discounting factor concept, such that this whole set of bullet points which are there in front of me, they would be considered using very simple examples later on in the 3rd week. So before we start our PERT and CPM, I will definitely try to cover these problems using very simple quantitative values, so that it will give a good idea to the students how they can be utilized, and also we will come up with the concept of very small assignments which need to be done by the students and submitted as per the norm of the NPTEL course. Have a nice day, and with this I will end the 8th lecture. Thank you very much.